Hey, there we go. Good morning, good afternoon, good evening, whatever time it might be where you are out there. Welcome back to the live stream. My name is Jeff Fritz.
Greetings, my excellent friend.
Greetings, my excellent friends. It's so good to see you. Today is, what day is today? Today is March 26th, 2020. We're going to write a little code with some friends today. We've got a guest joining us. I'm so happy that we're going to have a little bit of different content here today. I'm going to say hello to some of our friends here in the chat room. Gareth is here. Good to see you. Jean Valjean, that is Coder 24601. Good to see you. Is that Roro all day? Hello. Alan Bray, good to see you. Josh Kupka, howdy. Burnax, hello, welcome. Thanks so much for tuning in. Brian Lagunas. I just missed the Brian Lagunas raid. Oh my goodness. Thank you so much. Syra Lash. Johan is here. Martin is here. Thank you, everybody, for tuning in. And today, my guest, let me unmute his microphone. Let's get him in here. This is, let me introduce, this is Adam Hert. There he is over there from Solarwinds. Hey, Adam.
Hey, Jeff.
So good to see you. Thank you so much for joining us here for the stream today. And having a good day? How's things going?
Yeah, things are going well. Lots of meetings, but happy to be out of meetings and be on this call actually.
Right. Well, this isn't a call. This is just a couple of friends talking together, having a good time with a chat room that's going to, I don't know if they're going to be polite. They're going to be polite. Of course they're going to be. Look at that. Already 90% sentiment on the chat room. Love seeing that. Syra Lash says it's nice seeing a stream you can watch. Well, actually, this is a really good stream because Adam, I want to talk to you about SolarWinds.
Yeah.
Right, and APM technologies. Right, APM, that's another one of those TLAs, those three-letter acronyms that folks in our industry love to have. What's APM mean?
What APM means is a good question. So it's more of an industry term and less a term that users will actually know and use. And it actually means two things.
Okay.
So one, people say it means application performance monitoring, and then more so today, people say it means application performance management, which kind of encompasses not just monitoring the application, but also kind of managing the infrastructure behind it as well, and kind of just a more broader sense. But really comes down to, hey, is my applications doing what they're supposed to do?
Sure. And as we get the architecture of our applications more and more complex, and we think about not just a single server with a database next to it, but now microservices laid out using things like Kubernetes, and we have to maintain the state of all these different instances, that can be really tricky.
For sure it can. If Kubernetes is a great example. Like imagine if you have no monitoring in place at all. So, you're running this giant Kubernetes cluster that's doing all these complicated things. There's all these microservices, and they're all working in unison to maybe even just deliver a simple website. If something breaks inside of your Kubernetes cluster, maybe in some single service somewhere, how do you know what's broken, right? That just might look like a website is down or is slow or just like a little error somewhere. But to go digging through those different pods and nodes to figure out what actually went wrong, that's going to take you ages.
Oh my gosh, all of the system logs that you're going to have to go spelunking into, you're going to be cave dwelling for hours trying to find things across how many different locations. Goodness.
For sure. And it's actually maybe a good segue. For this call today on this Twitch live stream, we're actually going to share a little demo site.
Okay.
And maybe hopefully you can see my screen here.
Yeah, let me cut over to your screen here so folks can see what you've got there. There it is behind us. Hotel search.
We had a big plan for this. That we have this little demo site where you can search for hotels and it shows a bunch of different results. But the demo site itself actually broke and it says no results found. So there's supposed to be a bunch of different data here. But hey, the thing broke, and this is sometimes kind of the failure method that users can see. Technically, the website is still up there, but hey, it's not returning the data it's supposed to. It's broken in some fashion.
It's deprecated. It's degraded, right? It's not quite. It's working, but it's not working.
Yeah, and you know what? As applications get more complicated, there's such a gray area there. I mean, this website is technically up, right?
Mm,
It's working. It returned to 200 probably. It's showing us a page.
yeah.
But if we're a business that we're trying to get people to book hotels and pay us money, this is not working, right? It's not doing what it's supposed to. There's nothing there.
Yeah, yeah. And I think folks can go to this right now, solarsuites.info. That's a live site.
They can, yeah. So we might try and maybe even try to fix this during the call.
Okay.
And a lot of the data we're going to be looking at is coming from this specific site. So just so you don't have to type it out, I'll drop it in the chat. But
Fantastic.
it might make the data make more sense as we're going through the call.
All right, all right. So it feels like maybe there's a database connection issue here, or a misconfiguration. Maybe the database has a port blocked or something, or whatever that service is that's trying to serve this data just isn't behaving properly.
Yeah, and without monitoring, your guess would be pretty much as good as mine. Maybe the database is broken. Maybe there's a data tier somewhere that's the connection is broken. We'll take a look at the data and we'll try and figure that out.
Okay.
And just some little context. So this is running in Docker containers. It's running in microservices.
Okay.
So we'll kind of dig in the data and see how we can answer that question.
And I run a lot of my websites in Docker containers with a couple microservices at times. So this feels kind of similar to something that I might run. Okay.
Yeah. And, I think before we kind of just jump in and just kind of solve this problem, we should probably talk about proactive monitoring as well. So,
okay.
I should probably get my hand slapped here, but we actually don't have a lot of proactive monitoring set up on our demo site. So, what, lesson learned, this thing is broken and we didn't have an alert beforehand.
Okay, so proactive monitoring, just trying to unpack that name. That sounds like you want monitoring on your application before something goes wrong.
I mean, that's really it. I mean, this website is a great example. It's supposed to show hotels and serve a particular function.
Okay.
And the last thing you want to do is have, your users open a support ticket and say, I can't find any hotels, right? That's a bad thing. We're already behind at that point.
Yeah.
So ideally we have, some sort of alert, whether it be email in Slack or something. And ideally, before this actually breaks, like maybe we're running out of disk space. We'll take a look in a bit to see what it was. But in a perfect world, you actually know before this thing actually breaks and your website is never down, and you can actually go solve that problem before it completely breaks like it did here. And then second to that, at least when it breaks, at least you should know that part before your users do.
Sure. Okay. So let's take a look. What services do you have hooked up here that we can start peeling back the layers and see what's going on?
Yeah, good question. So we are going to show 3 different products from SolarWinds. One called App Optics, which does APM down to the code level and can actually show us what line of code or which custom function was slow or caused a problem. Covers the infrastructure. So in this case, will give us insight into our containers and the hosts that are running those containers. We also have Logly, which is a logging product where you can centralize all of your logs, do things like explore the fields in your logs without having to do searches. And we also have Pingdom.
Okay.
So Pingdom is, from an end user perspective, it'll run synthetic checks. It'll give you stats on your real users. So kind of gives that outside in perspective.
The basic, I can get to this website types of connections.
Pretty much, yeah. It takes
Okay.
a little step further that it can actually do some synthetic transactions where it does things like log in, make sure something exists on a site. So in this
Do
example
a search
right
for
here,
a hotel.
do a search for a hotel and tell you that it's not going to work.
Okay. All right.
So you know what? Let's actually check out Pingdom first for this example because it's probably the simplest. It kind of gives that outside in perspective. We know this thing is broken.
Yeah.
In what we were just talking about there for this broken demo site, Pingdom has something called Uptime, and I think we're not going to try and focus on these products too much and kind of talk about monitoring in general.
Mm-hmm.
But if we think about Uptime Checks, I think we've got one for our demo site. Let's see. But see, when the uptime checks, I'm just going to click Add New, so you can see what we can do here. We'll call it Demo Site. We can have this run at a certain interval, so let's just have it run every minute. We'll have it run, open up an HTTP website. You can do email and network as well. Put solarsuites.info in here. And then you can run these from different locations. This is actually super important. Part of monitoring is also reducing false positives. So if, what if you have a bunch of users in Europe that say your website is down, but you're hosting that website in North America and it's a network connection or a CDN or something halfway in between? You can monitor this from multiple locations around the world. Just kind of rule out that it's just an issue in one location.
Sure, that it's not some network provider that's outside of your control. The cable company for the Southwest isn't able to connect for some reason.
Yeah, exactly. I mean, imagine being woken up in the middle of the night because it's just some cable company somewhere. Like, that should be ignored. You should just go back to sleep.
Yeah. Somebody else's problem.
Exactly, right? It's important to know whose problem it is. So you can do things in here when you're running these uptime checks of, hey, how fast is this thing supposed to respond? So in this case, if we don't get a response back from our demo site in 30 seconds, we'll say that this thing is down. And then we'll just create this check. Now, the important thing about these uptime checks, because this is often one of the first places that people start with monitoring, is, hey, is my website up?
Sure.
But in the example right now, so this uptime check is going to go out to solarsuites.info, and it's going to check that it responded under 30 seconds, which it totally does. It's a fast site. It's going to make sure that it's got a HTTP status code that's not a 500 or not a 400. In this case, I think we're getting a 200 for this one. So the uptime check is going to say everything's fine, right? Which
sure
we know is not correct.
Everything's fine. That the browser at least isn't giving you a white screen, right? A 500 right? Error.
It's not completely down. It's partly down.
So hey, chat room, when you go to sites and you're getting stuff like this where you expect there to be some kind of search result, right? It feels like it's broken, doesn't it? I mean, that's something that you get frustrated with, right? I worry about those organizations that don't know they have a problem because they don't have that next level of analytics. For sure. Yeah. And let's see if it feels like it's broken. Yeah. There we go.
It's definitely broken. So the next kind of thing we can do, and it's important, like not everybody that cares about a website is going to be super technical, and Pingdom kind of it applies to a broad audience. Like if you have somebody on your marketing team cares about your marketing website, they can use Pingdom. We went through that uptime check there. It was pretty straightforward. The next thing we can do from Pingdom is transactions. So transactions aren't just going to go to your website and say up or down. You can actually go to a website, log in, click on things, make sure that elements are on a page.
Yeah. And folks here in the chat room, right? They're driving the sentiment down here because they're saying, yeah, it feels like it's broken. I don't like when I don't see any ads. It's clearly broken, and I don't like when I don't get any results. Amen to that one. When you don't get any results.
Pretty much. And if we've got some checks here for like logging into an AppOptics site, for example.
Okay.
But you could set this up for anything.
Now, I used to be a huge Pingdom customer because we used Pingdom to monitor NuGet and make sure from different parts of the world, NuGet, the .NET package repository, was up and running. So we had Pingdom all over the world, just like you were showing there, make those hits and just make sure that it was running. And just like I think you're about to step into here, make sure that we could find packages, do a search against one of the more common packages that we knew was always going to be there, and make sure we got results.
That's it. I mean, you can do it. You could basically check that there's text on a page.
Yeah.
In this case, once we set these things up and say, hey, I want to open the web page, I want to click on the login button, I want to fill in, the credentials, and then make sure there's something on the next page. I mean, that's kind of a simple transaction.
Sure.
Where this is super important, like the e-commerce site, our little hotel booking site. I want to make sure that the hotel loads up. I want to make sure that I can do a search. I want to make sure that I can check out and kind of make sure those kind of key transactions are up and running and responding within a certain threshold.
Yeah, yeah. Our friend Curious Drive here in the chat room has a good point. Let me put this up here for us. And they say the search results should be accurate, but there isn't anything in the database. Then the site should return something similar to that. Curious Drive has struggled implementing something like this themselves. Yeah, this is right why services like this are kind of important. And Adam, what you're showing here, these steps, these feel like other steps that my QA team may have written when they were doing integration testing. So it feels like this is another one of those DevOpsy type things where, you know what, they've got the good script of making sure that the site works, that smoke test. Hand that off to my production ops folks, and they can wire it up to a service that'll do that again and again.
It's very similar. I mean, under the hood, I think Pingdom actually uses Selenium, which is what a lot of people kind of use for their smoke tests.
Yeah.
So it's almost, in some sense, kind of Selenium as a service spread around the world with different nodes to make it easier for you.
Definitely. So, okay, so this is showing us the performance over time of those things, and we can definitely see it's performing well.
Yeah, so this one, so again, we didn't actually have a synthetic check set up for our demo site there. So we weren't, alerted proactively that one of these transactions is broken. We use this stuff for our production sites, which is super important. But, reminder to me, I'll have to set one up for our demo site.
Yeah.
The other thing, somebody mentioned, I saw in the chat there, I don't see any ads, so it's clearly broken. Just the last thing that we do have in Pingdom is also Pagespeed. So, we're kind of talking about developer stuff. Pagespeed is like Chrome developer tools. So you can basically have it go to, let's go to appoptics.com. Let's see if we have any big ads on here. So it basically gives you that waterfall type view and shows you what are the kind of slow elements. The classic one for Pagespeed, some third-party tools. We've got some spikes in load time. Sometimes it's third-party tools that are taking a long time to load. Sometimes, and you'd think this wouldn't happen, but people still forget to minimize their JavaScript. Sometimes people put in full resolution photos instead of something kind of small. So those small things add up.
They do, and it's they particularly add up in those regions that don't have great internet speed. Right, when I think about Australia and New Zealand, where they've got a thin pipe coming out to North America. Stuff they're requesting from the Pacific Coast in North America takes a while to get back there if it's pretty big.
For sure, yeah, and we can break this data out by region again as well, with kind of the real user stats, and you can see that, hey, maybe people are having a great experience in North America, but it's really slow in South Africa because you're not using a CDN and you use large images, right? I mean, that's going to cause a performance issue.
Yeah. Death Knight says we need 5 nines uptime for this demo site. You're right.
We do.
So some of those things don't look like anything's coming back. I saw a couple 0 bytes there. That looks weird.
A couple 0 bytes.
All right, there you go. There's one.
Oh, yeah. So we got a 302. So there's, a ton of information in here. So if you ever have, something weird like that, like a 302, and there's nothing actually, you're just being kind of redirected on here. Tons of information to dig in. But again, it's familiar. It's like Chrome developer tools. But these are just basically kind of this, you can go back in time and look at some of these instead of, have to go in Chrome developer tools and just keep hitting refresh.
Right. Getting that at the time this request was done, seeing all the headers, so useful.
Super useful. And people on the call are probably wondering, what actually broke on this, and I'm actually super curious too.
Yeah.
So let's troubleshoot this one. Let's take a look.
Okay.
So we didn't have proactive alerting set up for this, so it caught us off guard. The demo site broke. People are following along. Before we look at the data and figure this out, so this is running in microservices, running in, it's actually Docker Compose this one's running in, this particular environment. Any guesses without seeing the data of
what do you think, chat room? What do you think is causing the outage there? My guess is there's a database misconfiguration somewhere. There's a bad password for a database in a service or something. I don't know. Someone forgot to run a migration, Cyberlash is suggesting. Okay.
And maybe it helped that I think actually no changes happened. This was just running on its own and then died. So
okay. Well,
we will see.
Does our sample scenario here? Do they have continuous integration set up? If they have that scenario, maybe the DB instance died. There's another suggestion from Cyberlash. If they have continuous deployment set up, they may have deployed something that doesn't match, is requesting a view or stored procedure that doesn't exist.
All good guesses, and this is a scrappy little demo environment, so it could be any of those things.
Oh yeah.
So now we're actually going into App Optics here.
Okay.
And we're going to jump into the APM side. So we're going to take a look at all of our services that actually make up this demo environment.
The complete architecture of it.
The complete architecture of it.
Okay.
Yeah. So what we have in here is we have our web tier service. So this is the one that the users are actually interacting with. So when you refresh solarsuites.info, you're making a web request to our web tier.
Okay, makes sense.
We've also got a booking service. So booking service actually gets information from the database and helps with some booking and actually returning some of those results. So we might see something there. Auth service, but probably not that because we weren't even logged in. There's an API, possibly. But we'll dig into...
Now, hang on, before you navigate, we're kind of hiding what was happening there because of where our cameras are. It kind of covered the number of errors that were being shown. Let me just turn that off real quick so you can see behind Adam's camera there. There's some errors being reported over there on the side. So there's something going on. Okay.
Little spike, yeah. So we'll jump into our web tier here.
Okay.
And first off, a couple of things jump out. Our average response time compared to a week ago is up 94%. So probably not great.
Yeah.
Request volume isn't, right? There's nothing abnormal about the traffic hitting the site, which is always important to look at. So hopefully people are somewhat familiar with the 4 golden signals that Google put out in their, I think it was in one of their SRE books. But the 4 golden signals are latency or average response time, volume or request rate, error rate, and saturation. Saturation can mean different things. We're showing CPU here, but saturation for a queue, it could be different for different applications. It could be queue lengths, it could be buffer size, it could be memory on some machines or disk I/O depending on what you're doing. But we're showing CPU here. We're not really troubleshooting a latency issue. The website seems fast, it's just not showing the right data. But if it was a latency issue, we've kind of got these 4 signals kind of right there compared to a week ago.
Okay.
Also calls out a couple things that, hey, the latency is 94% higher, and we're spending most of the time waiting on remote calls to the booking service. So it gives us some context about, kind of where we're spending our time in this application. Also, apparently, we're not load balanced properly, which makes sense because it's a scrappy little demo environment.
Sure.
So what we're actually going to do on this one,
Mhm.
we're going to
That's
jump
a
straight
lot of
to.
exceptions. Oh my goodness.
It's quite a few. That's in the last 60 minutes. We got 4,000 exceptions. So
Okay. And does that number refresh every 60 minutes? Well, is it a rolling total for the most recent hour?
it is. Yeah.
Okay.
Yeah, for sure. And we've got a bunch of exceptions in here. So we've got hotel not found, which is predominantly the exception that we're seeing here. I've got a 500. Got a failed to open a TCP connection. We have some null pointer exceptions. Hopefully, if you're running a production website, you don't have this many.
Yeah, the null references, the null pointer exceptions. Oh my gosh, that's like the bane of our existence. Why didn't you catch that ahead of time in a test or something?
Pretty much. And one of the things we can do on here is, looks like some of our errors actually cleared up earlier today. But one of the questions I would have coming in here and seeing all these errors and exceptions is, okay, when did this start?
Sure.
Like was there some sort of an event? So let's go back. Okay, so we went back 24 hours. So now we're looking at a 24-hour time period. And we can see these started around 2 a.m., basically overnight.
Okay.
Which makes sense because I checked this demo environment yesterday before this stream, and it was working properly. Now it's not. And for the most part,
what did you do, Adam?
what did I do? And for the most part, it is these hotel not found exceptions that come around that time. And this is just like if you imagine we're an SRE and we got an alert or we have to fix this right now, maybe it's 2 a.m. and we have to go solve this problem. We actually don't have to do much more. We can just click on this last occurred, and it'll take us to a trace, which is like a specific example of a request that contain this exception, so we can get some more insight.
Okay.
So,
oh my gosh.
In here, this is the actual basic flow, or almost like the control flow of the application.
Gotcha.
So we're starting in the web tier. We're moving, which is Ruby. We're moving into the Rails framework. Our exception is actually in the Faraday layer, which is like, for people not familiar, it's like HTTP middleware for Ruby.
All right.
We make an HTTP call using the native HTTP, net HTTP in Ruby down to a booking service. So this is actually a distributed trace. We're actually going through the web tier, which is written in Ruby. We're making an HTTP call to our Java service called the booking service, which is the Spring framework.
Okay.
And then eventually makes a database call.
Makes sense.
That all gets returned back to us. And in our Faraday layer, we were basically looking for some hotel results. And from our Java service, basically said, doesn't exist.
Right.
Like the hotel you're looking for, it just isn't there.
Now that little shield icon that you have above that, is that the point where the error occurred?
It is. So this will actually give us the exception, and this will give us the back trace to where that exception occurred. So we basically made that call from our Ruby application. We're expecting results. We didn't get it. We threw an exception, and now here's a backtrace for it.
All right. That's a lot of data.
It's a lot of data. I mean, for a developer, this makes sense. I mean, this is showing them exactly which line of code, through that exception, so they can go kind of dig into that. And then what we can do, take this a little further, is like, okay, so our web tier that users are interacting with, it said no hotels found when it went to look for that. And we've got the URL, so it was looking for the specific hotel. It's like some index in a database. We're actually using MongoDB in that case.
Yeah.
And it just said, nope, doesn't exist. We can move down into the actual database call down in our booking service and say, what query were you making?
Ah, there we go.
Right. So some people our sentiment's probably going to go down because we're showing MongoDB instead of SQL calls.
Nah,
But,
Mongo's great. Oh my gosh. Although there is a question. I'll let you finish talking about the query, but we do have a question about .NET Core.
Oh yeah. So actually for .NET Core, you use it basically exactly the same. For in-app optics, we support I think it's about 8 different languages, and we support classic .NET as well as .NET Core. So it really looks and kind of feels the same.
Fantastic. Is there anything that you needed to add to the application? Any kind of plugin or something in order to enable this type of tracing, or is it just attached onto the Docker container?
Yeah, good question. I've actually I'll pull it up in a minute, but it's dependent on the language.
Okay.
So for Ruby, for example, we have a gem. So you just include our gem, and you're off and running. For PHP, it's a PHP module. For Java, it's a Java agent, and then .NET, it's part of the runtime. So a little bit different depending on the language.
Terrific.
Yeah. And kind of in our troubleshooting flow, okay, we know hotel wasn't found. We can see the query being made here, and that didn't return any results. We can also see, which host was this made from, which region was this in. Here's a query again. We've got a process ID if you want that. And also important here, our actual database that we're looking at.
Ah, okay.
Right? So we know the query we made. We know which host it came from.
Sure.
We know which database it was made to. And that database said, nope, hotel doesn't exist.
So now the question is, does that record actually exist does that record actually exist? But also, is this doing that same search that we were just doing, and it's doing a find one?
Yeah. Both good questions. And from here, since the database said, hey, that doesn't exist, and essentially know this is built in Docker containers as well, I'd probably go back to kind of the infrastructure side and say, did that Docker container just disappear? Which it probably did, because this is a scrappy little demo environment. And probably just completely died off or ran out of disk space, which has happened before. But we've got the infrastructure side of that story in here as well. So we can dive into that and actually see, hey, did that container actually disappear?
Really? Okay. That's pretty cool to be able to see a little bit more as to the running containers. Yeah,
and the one thing that, since somebody brought it up of, how does this work for how do we actually
.NET.
how does it work for .NET, and how do we get this information? So let me pull something up here.
Okay.
Okay, so we've got 2 demo environments. We've got one running in Docker Compose and one running in Kubernetes.
Okay.
So one of the things we can do, let's take a look at a deployment in Kubernetes. Take a look at our booking service. So to get this up and running, we're going to use Java as an example. I'm Canadian and I say Java all the time, and people always correct me and say, actually, Java.
I won't take offense to that, okay?
And Java was actually, I think it was created at the University of Calgary or Edmonton. So, let's say Canadian language.
There you go.
Java.
Right. Works for me.
So what we do here is actually just in the arguments that we're setting for our command.
Mm-hmm.
So our command, in this case for this Docker container in Kubernetes, is Java. And in our arguments, we are setting this Java agent one, which actually went over 2 lines, unfortunately. But basically all we're doing is we have this little jar for app optics in this image, and all we're doing in our Java arguments is pointing to it, saying, hey, use this Java agent.
That makes sense.
It.
That's easy.
Yeah, everything else is automatic.
All right. That makes a lot of sense. Hey, Webface CA here. Greetings from Ontario. There you go.
Oh, nice.
Some more Canadians. I'm sure there's a couple other Canadians watching right now.
The question is, does he say Java or Java?
Yeah, which way do you say it? In Ontario. seeing a couple more friends pop into chat room. Java. Okay.
Maybe I'm the only one.
Don't know.
Go ahead.
Some of the pronunciation around the things that we have in tech, right? It's not until you actually see and you talk to folks in person that you actually come across, wait a second, is that the way we pronounce those things?
Yeah.
For the longest time, I was pronouncing Skype, Skype, because I talked to all these German folks, and the E at the end they pronounce as an A. I was like, oh, no, it's Skype.
Yeah, I don't know if there's much argument around that one. I think it's just Skype.
I know.
Joe, one of the things we came into this trace kind of looking at for a particular exception. Yeah. So it took us kind of right to this detailed view.
Mm-hmm.
There is kind of this alternate view as well, where it's just like a little bit simpler. It just kind of breaks down the time. It just kind of helps teams work together a little bit. Not everybody can read that kind of control flow waterfall of a trace, but it's kind of an alternate view that calls out what the slow thing is. That's often kind of the most difficult part to troubleshoot. Is exceptions are relatively easy. They're straightforward. They usually have a backtrace. But when something is just slow, it's a little bit tougher.
Definitely. The how you pull that apart, get that next level of analysis, takes a lot of skill to have that insight.
Yeah, exactly. And just gonna refresh this. So, when we're looking at the errors in there, we saw that they actually ended maybe 20 minutes ago.
Yeah.
So I was curious if it was working again. It turns out it is. And I do want to kind of show another trace where something is just slow. So you can think of loading this up, maybe clicking on one of these hotels. It's decently fast right now. And for the people watching along, if you want to click around in that site, if you happen to have Apache Bench or something kicking around, feel free to send a little traffic at it. We're actually going to put a dashboard into the chat so you can actually see essentially your own data and the response time from this little demo app in real time. So let me pull this up here.
Okay, so it's solarsuites.info. We put that link into chat just now again so that you can click through and you can see the web. You can start tinkering around the website, see what's going on there. There we go. There's a nice link.
Okay.
I'm looking for where you're pasting.
I think I tried to paste it in. There we go. What do I have to log into Twitch to operate?
You may
need
need to. If you drop it into our chat on Skype, I can paste that in for you.
Let's do that. Yeah.
There we go. I will copy that and share that link. So now our friends in chat can take a look at the dashboard as we're tinkering around with it. And please, friends out there, if you're watching us live, click around the website there. Let's generate some traffic. Let's make this website a little busy here. Those are friends at solarsuites.info. And if you're watching the recording, we're not watching this right now. Or then.
If you're watching the recording, it doesn't work quite as well. But one of the things we want to show in here, so in-app objects, you can create whatever custom dashboards you want. So we can move these charts around. We can make a dashboard that makes sense to us.
Sure.
But if you have a really complicated application, maybe you have a chart for like a Kafka queue in here, and then a queue consumer, and you're making sure that both those things are kind of in line and you don't have a backup somewhere. This is a pretty straightforward example. We've got this time series from our web tier, and we're actually breaking the components down. So for our web tier response time, we can see that, hey, about 142 milliseconds on average is being spent not actually in the web tier, but downstream in the booking service, which makes sense. It's a distributed application. And then we've also got our request volume for the booking service and the web tier, both on this chart here. So, if we have a lot of traffic and we start to see a slowdown, which looks like a few people are visiting and it's starting to go up a little bit, it'll be interesting to see the relationship between these two things. When you're building an application and you're kind of dreaming up the architecture in your head, it might make sense that, we'll have this web tier on a single host, and we'll have the booking service on a single host, and everything will be perfect, and each request will spend half its time in each of these things. But in reality, we might be spending most of our time on the booking service, and that's a choke point for us. So if we can see the request volume for both of these services in one place and see kind of the latency breakdown on our web tier, we can actually get that information. We can understand, hey, where's the choke point? Where's the slowest thing in this application?
Right. Some folks are trying to get to SolarSuite's info, and they're saying that it's unable to find it. You need to know it's not an SSL protected site. So don't put HTTPS on that. It's HTTP to get through to this one. But there we go. They're getting through now.
Ah, nice.
So yeah, let's generate some traffic here. Let's make that. Let's fill up that graph.
Yeah, we'll see. So I don't know how many people we have on the chat there, but we'll watch the request rate and see if it goes up, and we'll see where the choke point is.
All right, we got it looks like about 50 people are watching. Cyberlash is chiming in here. Yeah, it's time to plug in certbot and let's encrypt.
Well, let's we'll give this one a minute here.
Sure.
But I do want to show. We'll take a look at just a slow trace, and we'll look at this performance in just one other area.
So I'm navigating around a bit here. Getting all the way through. I'd like breakfast with mine. Yes, parking. Early check-in would be amazing. Log in to proceed. I'm not going to finish and go through there, but London, that's nice. I want the premier apartment. And definitely need parking in London. I want that off-street parking. So, we're definitely seeing a bit of traffic come through here. All right.
Nice. We'll check the dashboard there in just a minute.
Webface is asking, is SolarWinds the same company that does SolarWinds Take Control? I'm not familiar with that.
I think it is. I think it's part of the MSP business. So okay. SolarWinds, a fairly large company, so they do mostly known for network monitoring. Been around for a long time. They also do some MSP stuff, so like kind of a managed service provider aspect, and then of course the admin perspective, where we're showing that code level visibility, these SaaS-based products that kind of help you manage your websites.
Okay.
So, we were looking at the dashboard and watching the volume go up there a little bit and the request rate. We can also look at our web tier here. We're filtered down to the host that everybody's interacting with, and we've got a scatter plot of basic request latency.
Yeah.
So somebody out there actually had a slow one, so we can filter down here. And we can basically draw a box just around these requests. It's super easy.
Oh wow!
It's super nice, especially if you're an SRE at 2 a.m. and there's just like a weird issue where you have some outliers and something's really slow sometimes.
Yeah, show me just these ones.
Exactly, right? And it just helps you filter through the noise. But I don't want to look at 5,000 requests. I want to look at the slow one that happened up here where somebody had a bad experience.
Yeah.
And then, this happened at 11:49. I'm on Pacific time. So this happened just a couple minutes ago. This is probably one of you guys out there that just visited the website, and it took about 1.35 seconds to return a result to you. So if we click on that, it breaks down what was slow and where we were spending our time. So we made this request to the web tier. It took 1.36 seconds. We spent 8% of that time just chewing through some local application. And then 92% of our time was spent on remote calls. So, we've kind of talked about the architecture of this one, but in this case, we spent 92% of our time on these remote calls.
That's okay. Seeing that breakdown now and knowing from our interactions, this is very clear to see. Here's what's going on. Our friend Curious Drive here in chat actually says, that's pretty awesome.
It's, if you think about the kind of the opposite of this, of not having a solution like this, troubleshooting latency is a giant pain, right?
Yeah.
I mean, especially in distributed services like this,
it
you can
becomes
do little
pointing fingers. No, mine's really fast when we make requests to my service.
It does, and what if it's, if you think about it, you can try doing like logging using the old print statements and logging, measuring time and saying, oh, it took so long to do this, and that used to work okay, right? People used to use logs for years to troubleshoot stuff like this, but once you're into distributed services, like, are you going to log this across, all of your containers running in Kubernetes? What if it's the wrong one? You have to track the context and generate your own GUIDs, and it becomes a giant pain.
Oh my gosh. And unwinding it then and trying to stitch back together, well, we went from here to there.
Yeah, and this kind of gives us the first level of information of, okay, so we made this 500, half a second basic call to the booking service.
Sure.
And, if you were making a call out to, I don't know, a Google API or something you didn't own, this is where you'd stop, right? Be like, okay, the external API was slow. But since the booking service is an internal service to our demo environment, and we do automatic distributed tracing, we can actually take this further and say, okay, so why was the booking service so slow?
Right.
Right. So then we can click through, and now it's kind of like the many layers to an onion essentially. We started our origin transactions in the web tier, but now we're taking a look at the booking service that took 570 milliseconds, and we spent most of our time waiting on the database.
Here we go again, that database.
Always the database, yep, especially MongoDB. And then we break it down, and hey, we made these two queries 63 times, right? Probably some n+1 query loop.
Sure.
And then
if
we really want to,
yeah, what are you doing making that find query 60 sometimes?
Yeah, exactly. I mean, this, we talk with our customers a lot, and we kind of somewhat attuned to problems in the industry. N+1 query loops, everybody has them. Like, they're everywhere. It's a very common occurrence.
Okay.
You think it wouldn't be, but it's just such an easy thing to do, right? You make a query and say, hey, give me a list of things, and then for that list, make all these other queries. I think it's logical and it makes sense when you're writing the code, but once you do that in production, that can be a lot of queries.
Oh, for sure. Okay.
And for the developer too, I mean, this is kind of high level information. We got our answer. We know why this is slow. But if we ever want to see this in kind of the greater context, we can also jump over to that kind of control flow view and understand, hey, that half a second thing we were looking at, it was just one piece of this. We kept making these calls to our booking service, but this is the thing that we're looking at right now.
Okay. And clearly it's going to affect the rest of the stack that depends on it.
Yeah, I mean, this is, especially in this complicated world, I keep coming back to Kubernetes because it is complicated and it introduces these complex problems. But, we're in the booking service and there's an n+1 query loop down in here. But for the end user, like, we're basically making these n+1 query loops like 3 or 4 times. I mean, that issue is compounded and it's making the user wait 1.3 seconds.
easy to clean up. We know those N+1 problems. That's easy to address and figure out. But when it becomes visualized like this, oh my gosh.
It jumps out a little bit more. And, going back to the kind of the old troubleshooting flow of, we're going to throw a bunch of log lines in there and we're going to try and piece those together. And there's still a bunch of people doing that. I mean, starting with logs is one of the natural parts of monitoring. And I've talked to a lot of people that have done this, particularly in Kubernetes, to try and solve this problem. But they do generate their own GUIDs, their own unique identifiers. It's super common. And then they try to log messages with that GUID across Kubernetes or any kind of distributed systems, and then try to piece that together. One of the many challenges with that is that you have to get everybody on board, and it takes a lot of work you're essentially creating your own instrumentation where you have to generate this GUID, you have to pass it from service to service, you have to now log messages with that, and hopefully all of your developers across these services do exactly the same thing, because that's the only way it works.
Oh my gosh. So you've invented your own API at that point that these folks are communicating back and forth with each other, and you're going to need to version that, and oh my gosh. Okay.
And it's a lot of people have tried to solve that problem by themselves, and they run into the headaches that you're talking about. I have yet to talk to somebody that says, "Hey, we did this thing and it's working really well for us." It typically doesn't.
Okay.
So one of the things that we did, so we have these APM libraries, for Ruby and Java that are producing this for us, and to build a trace like this, we're already creating essentially this GUID and passing it between services. We just take care of that automatically, but we also make that GUID available to the different login libraries. And what that enables us to do is it's just a config option. You can just turn this on. But then you can have basically the GUID attached to all of your log messages just automatically. My internet is slow today. We'll see if this loads up.
We wouldn't happen to be pushing something like video back and forth from each other.
Right, yeah.
There is a little bit more going across the network today. So.
Okay, here we go. Finally lit up. So what this allows us to do is go from that trace that's kind of showing us the slow things and actually go straight to the exact logs from that transaction. So it's kind of solving that logging and distributed systems problem just by having the libraries in there.
Terrific.
And I should mention too. So AppOptics does have a developer edition, which is totally free.
There we go. Okay.
And it is a little bit limited in kind of like the number of traces and stuff that you get, but the libraries and this kind of logging option, you can just use that and just say, hey, forget about traces, and just attach this GUID to all of my logs. So don't try to solve this problem yourself. It's been solved before. Go use a tool like the AppOptics Dev Edition, or there are other tools out there that have done this. It's I haven't heard of a success story where people have done this themselves and it's worked really well.
And right, the great thing about having a developer edition for a tool like AppOptics is you've gotten started at the point where you started building your application. You know some of the things to look for as you're building it. Oh, that's a mistake. This shouldn't be happening. That's an error scenario. So now when it comes time to deploy to your production area, now you can pass on to the folks in operations and say, hey, we were using AppOptics in development. It worked great for us. Here's the types of things you want to look for. And they go and turn on the full production instance of AppOptics. And when they deploy and they scale up, and they've already got some cheat sheet notes from you as a developer that say, hey, here's some things to keep an eye out for.
Absolutely. And there's also one more kind of developer tool in here.
Okay.
It's a thing we call trigger trace. So it's very developer centric, but if we go back to that heat map, so a lot of times people are maybe sharing like a staging environment, or maybe you just got a fair amount of traffic on what you're testing during development time. If you just made a request to like an endpoint that's kind of sparse, and you're trying to find, or maybe like put some very specific parameters on a request and be like, I want to see the performance of this, and I want to see what this did.
Yeah.
Good luck finding it in this 25,000 requests we're looking at here.
There's a lot going on there. Yeah.
There's a lot going on there, and albeit it is easier in staging when you have less traffic to find those requests.
Sure.
But you still don't want to take your time, drawing boxes and finding those particular ones. You can filter this down by, things like host and transaction. But when you're a developer, you can also just set a header, like basically when you're using curl, and it'll actually return you. It'll make sure it traces it, and it'll return you the trace ID, basically just in the response headers, and then you can just plop that into the URL up here and look at the exact thing that you were looking for.
Oh, nice.
It's kind of an easy tool for developers. Again, especially when you're working in distributed services.
Yeah.
The AppOptics Dev Edition is free, and you can just go use it for that.
Yeah, our friend PD James here in the chat room dropped a link to that, so folks can click through and find that. Thank you.
Yeah. And Jeff, you're talking about kind of developing stuff in staging, and then moving that to production.
Mm-hmm. So sure.
That sort of flow of, hey, let's see what this actually looks like and make sure it's performing properly, and that helps.
Yeah.
Also, just developing in distributed services can be a giant pain.
Yeah.
I kept pitching the AppOptics Dev Edition. It's not going to be that helpful if you're just making HTML, right? It's only
it's static.
But a lot of people have staging or development environments that are now running in things like containers.
Sure.
And maybe you're only working on one of those things, right? Like maybe we're working on the booking service, for example, and we're just using the rest of the staging or development environment that has the web tier and the API and the auth service and all of this stuff in there. And I want to know, hey, if I make a change to the booking service, what does that do to these other things?
Sure.
That's where you can use the synthetic transactions in Pingdom to run the data through your development environment.
Okay.
You can use the distributed traces in AppOptics to see, hey, how are these changes taking effect? And what you don't have to do is go do a bunch of print statements in all of those other Docker containers out there, right? That's time consuming.
Now, what you were saying about Pingdom with the synthetic traffic generation, there was a question we got a little bit earlier. I want to come back to this for a second from Elliot Brand, and I think this is a little bit towards your point there. Do any of the tools test the number of concurrent users a website can handle? Do a little bit of a stress test?
It's a good question. So we don't create the stress tests.
Okay.
We just monitor the results of it. So we don't have something like a Apache Bench as a service or anything like that. But you can certainly see the results of it in there.
So you can couple the two together, then Apache Bench with what you're seeing here on AppOptics, and you'll be able to zoom in and get all of those details about what happened.
Yeah, exactly. And I'm just going to refresh a page here. So this is kind of a good example. I hit the refresh button. We're just going to take a look at the stats from this website when there was a little bit higher load because everybody was visiting the demo site. But hey, we can see here, we certainly had, looks like we were about up to 90. Our biggest spike was about 320 requests a minute here.
Nice.
Which is not bad.
All right.
And what's interesting here, remember this, so we were looking at these traces where the web tier makes like 5 calls to the booking service. That's reflected here too, right? We put this both on the chart. So when we had 321 requests a minute to the web tier, our booking service went up to almost 1,400 requests in a minute. It's quite a bit.
Yeah. It's
reflected
unexpected.
In our latency.
Yeah.
Right. We see the latency of the web tier. Hey, most of the time is being spent on that booking service. So, it's pretty simple data. But this load test was created by, the users on the stream here, but you could use Apache Bench to replicate the same thing.
Cool. Now, and that goes back to that N+1 query problem that we saw a little bit earlier.
Yep. I mean, if you're doing this in development, you would have found that problem before it hit production, right?
Oh,
You
sure.
could see that, hey, we're waiting on the booking service, and we're waiting on the booking service because it's doing n+1 query loops.
Sure. You'd run a test on a really big range of time and wait to see, hey, what's this reflecting? What's this showing?
Yeah.
Coming back.
And I think a lot of people could say that the problem was really we're running MongoDB, but really it was even MongoDB was used improperly. We did an n+1 query loop.
Yeah, with great power comes great responsibility and great database problems when you don't use it right.
Yep, exactly.
So, okay, and I love seeing that it's continuing to see a bit of a spike there. I'm thinking some of our friends in the chat room are hitting refresh still.
Yeah, it's great. It's nice to see.
So, love seeing the graphs that you have there really track nicely. You can definitely see the patterns in the behavior and where and how one thing is affecting the next. Really cool to see.
And let's kind of on the topic of development and kind of getting into the details. Let's check one more thing. So we can see that we have this spike in the booking service.
Sure.
We're actually looking at percentiles. So we've got like the P99, the P95. So basically what that tells us is there's a bit of outliers, right? Like there's the P50 is way down at 96 milliseconds, but the P99 is way up at 130. So there are some requests that are slower than others. The booking service runs in Java, and I always think, is there a garbage collection? Can we do some tuning for that?
Sure.
So we can actually jump in to our dashboards. Because when you use our Java agent, we actually automatically collect JMX stats as well.
Okay.
So we can pull this up.
While that's loading, we just got a raid from our friend Code Rushed. Thank you so much, bringing over a couple of viewers to join the stream. Appreciate that. Friends that are just joining the stream, my name is Jeff Fritz, and we're talking to Adam Hert from Solarwinds. We're learning a little bit about APM, about application performance management, using app optics is what we're looking at right now to try and figure out what's going on with a slow website in this sample that Adam is showing us.
Yeah, and what we're looking at here, so we're looking at both the application's performance, so response time, volume, and even status codes. And we're going to look at that right alongside the JMX metrics for the booking service on that host that everybody's interacting with.
And after you load that up, we've got an interesting side question about geographic locations as we load this up.
Okay, geographic.
So the question, yeah. So our friend Curious Drive asked a couple questions earlier. Asked, well, does it show the geographic locations of some of those requests also? Coming back to a little what we saw about pingdom earlier, where it would show, oh, you know what, this is something isolated to this part of the world is seeing a problem.
It definitely does, yeah. So we actually have like a geographic map. We can see where users came from, what their performance is like, and even what browsers they're using. So we'll take a look at that data in just a minute.
Oh, fantastic.
So on this one, we kind of speaking about, running load tests, talking about, how do these things perform in development. So we're looking at the past 6 hours here. So we can see this big spike basically start where we gave you guys a link and we said, hey, go
yeah, we're going to blame you, Twitch chat room. What are you doing out there? Look at that.
And what we can see is we've got some crazy request and response time, but we can see garbage collection time going up with our request volume. Well, our status codes are still 200, which is great.
Yeah. Good.
And something to always watch out for is, are these kind of big stop the world events? Are these causing like a big spike in your P99 and your P95 latency? And is there some tuning you can do here? Like, can you, do garbage collection a little bit more often? Does it make sense to use a different garbage collection method? Maybe tweak your young gen and your old gen kind of maximum limits in there. So there's a ton of stuff you can do in to tune a JVM, and really the results of that and the monitoring of that can be right on your dashboard here, and you can see it live.
So it's really cool that you showed this. Something that I've seen some folks talk about in the ASP.NET world, where I spend a lot of my time developing, is that they went from the ASP.NET Core 2.1 to the latest supported version 3.1. One of the things that they changed in the framework, Adam, is that they reduced the text allocations for the web server. So instead of allocating memory for each request coming in, they keep reusing the memory for all the strings. So the memory allocation drives down close to 0 for new requests. And people are seeing graphs like what you're showing there when they convert over to the new one, exactly like we're talking about. They've optimized how it does garbage collection, and you're able to see the graphs go down towards 0. It's really cool stuff to see. And visualize like this too.
I think some of this stuff we almost kind of take for granted. We think, and it's an easy problem to solve sometimes if you're seeing high garbage collection or something is just slow, especially when you're running in the cloud.
Yeah.
You throw more resources behind it, right? You can forget about this problem. You're like, you can go to some finance person in your company and be like, we need, the largest instances in AWS, and we need more of them.
Right. You know what? I'm going to just push that slider over from 1 server to 2, and it's going to cost us another $50 a month. Is that okay?
Yeah, right. It
makes the problem go away.
It does make the problem go away. I mean, it makes a lot of these problems go away, but you can't just kind of keep doing that forever. There's a lot of these problems can actually be solved kind of in the correct way, and can save you some money too.
The sins of making those poor performance decisions in how you wrote code are solved by just $50 a month. Slide that over and we'll get the next size server. We'll get 1 more server. No big deal. Finance is okay with that. Instead of spending a couple developers for a couple days, we'll push the slider, right? And look, they're laughing here in chat. .NET Kyle is here and Curious Drive. They're laughing. But it's true.
It's the easiest. It's the fastest solution most of the time, right?
It is.
Yeah, I'm not necessarily saying don't do that, but sometimes take a look at the stats.
It's literally the visualization of technical debt.
Yeah.
And the finance people, they now can see it on the balance sheet.
We're getting closer to that. I mean, teams are working closer together. Eventually, probably gonna be years from now, you're gonna have an accountant, to ask you about your young gen allocation.
So, all right, I'm going to tell a story for just a second. So, I used to work for a company. It was a software as a service company, and we had big database, just like you're talking about, Adam. Big database, and we were optimized for school districts, and schools had their most activity on the system in early to mid-April on a Friday. Always, it was that first or second Friday in April, you would see the most activity on the database. So each summer, they would see, okay, we've made how many more sales for the next school year, so we need to order this much bigger a database, because we had physical machines. Of course, we had physical machines. And need to get that installed and running. And it was only for those 2 days a year that they needed it. Well, wouldn't you know, the queries against the database weren't optimized, but as they're spending hundreds of thousands of dollars on database machines, the finance folks are like, is there anything we could do to make this run better? Instead of adding new features, can we just take a couple weeks and make it run better so we don't have to buy the next database next year? And sure enough, we ended up saving money and not buying the next database. And it's like, that's right?
Yeah, it makes a lot of sense. And, that story reminds me, that's basically how Amazon Web Services came to be, right? They bought hardware for the Christmas season and for Black Friday, and they figured, we'll rent out this hardware for the rest of the year.
Yeah. Oh my gosh.
While we're kind of talking about we're basically spending a lot of money in the cloud.
Nothing wrong with that.
Let's take a look at one more thing here. So, the same problem, and we keep coming back to Kubernetes, so hopefully this is actually an interesting topic for the people watching this. But if we have that problem where there's a slow service, and we say, hey, let's throw some more horsepower behind it to solve our problem, that problem also exists in Kubernetes, but it's just slightly different.
It's hidden from you.
Right, and it's whenever you give something more horsepower, you're kind of taking away from something else. It's a bit of a balance. So let's pull up. I've got some Kubernetes stats in here.
While you're hitting that, our friends at the Twitch developer channel just raided over to us. They brought a bunch of viewers, and Matt Auerbach from Twitch is here joining us. Thanks so much for joining us, Matt and John Bulava. Hello, hello. I'm joined by, my name is Jeff Fritz, and for those of you who haven't seen me before, we're talking a little bit about application performance management with Adam Hert from Solarwinds. We're looking at app optics right now. How's it going out there, friends? And learning about, well, how do you track the performance and the allocation of things on AWS, on Azure, on, right? Maybe you're using Kubernetes, and we're taking a look into here at a little bit. So great to see you, friends. I hope you had a great stream over there on the Twitch dev channel. Welcome in. So, all right, now we're taking a look at something that's Kubernetes.
Yeah, so we are diving right in here. So, actually, before I dive right into the stats, let's take a look at our Kubernetes config again.
Okay. And can I see some ones in chat if you use Kubernetes on an external deployment? Right there, a lot of folks are using Kubernetes.
Okay.
Can you drop a 1 in the chat room if you are?
So we'll take a look at this booking service again.
Yeah.
So in Kubernetes, you basically describe like your end state of what you want your cluster to look like. So when we're looking at our booking service, which we've kind of focused on throughout this call, it's kind of the choke point of our application a little bit. The web tier keeps waiting on the booking service, which is making inefficient calls to MongoDB. In Kubernetes, you can say, hey, how many of these do you want?
Right.
So for the booking service in our little demo environment here, we said we only need one of these. But now that we know that the booking service is the slowest thing and it's our choke point, I could easily go in here and say, I want 20 of these, right? And then Kubernetes is going to take care of the request distribution. And you know what? The booking service isn't going to be the choke point anymore. Booking service is going to be fast because we have 20 of them.
Yeah.
Right. And we can do that same thing for the web tier. Is that a good thing? It's an easy thing, right? It's an easy fix if we know that the booking service is our choke point.
Yeah.
But what does that do to our cluster, right? So eventually it's good to look at, I have to refresh this, my screen is looking funny. Eventually it's good to look at the cluster and say, hey, where are all the resources being spent, right? Because you have to balance that. What's the slow thing? What's the important thing? Right? If you go back to our hotel booking example, it's important that people view hotels, search hotels, and book hotels, right? So if I look at my Kubernetes cluster, I want to make sure that those things are fast, and that's where we're spending our resources.
I also feel like there's a concept of you want them running hot. You want them at a higher percentage utilization so that in the cloud, whether it's AWS, Google, Azure, you're using as much of those resources as possible.
For sure. Yeah, I mean, if you're paying for them, you might as well use them, right? You don't get a deal if you use 80% of them.
Or if you don't get a deal if you're only using 10% of them. Oh, look, I've got so much available. So what? For
sure. And part of it as well, so it even gets a little bit deeper of, hey, how do you build your cluster if you're not using like a managed cluster?
Yeah.
Do you want a lot of memory? Do you want a lot of CPU? What kind of resources do you want to put behind this thing?
And that's dependent based on what your application does. We can't tell you what your application needs, but how you built it is going to dictate those.
Exactly, and we can use App Optics to get some more visibility into, hey, what is our booking service consuming? Right? Like what resources do we need to feed it and to support it? So this is one example here. So we're looking at the average memory usage, the average RSS by Kubernetes spec name.
Okay.
So I can go in and I can go name my pods and name my services, and I can see that, hey, on the average booking service, so imagine I had 20 of them.
Sure.
The average one is using 373 megs. It's actually pretty small. But then, so I only have one of them, right?
Yeah.
So the average and the sum is the same.
Yeah, don't need that much memory for that. Okay.
Yeah, just a little Java thing. But then I can also look at and say, okay, if I take my all of my service and say, this where the replica sets come in, what's actually the total? What's the sum of memory by these things? And now in this case, the booking service is pretty far down the list.
Yeah.
Right. Because I've got more replica sets of the web tier, which is probably backwards because we know that the booking service is the choke point. So really, this is an unbalanced deployment in our Kubernetes service because booking service is the choke point, but we're giving more replica sets to our web tier, and that's where we're giving our resources.
Nice. Okay. So we've got a little bit of insight there just because we're looking at those graphs. I agree. OP1 in the chat room here says this is really neat. I agree. And it feels like, Adam, it feels like the next step after seeing some of those graphs is to be able to almost make a recommendation, right? To be able to say, hey, this feels like you've got more replicas of this thing and you've only got one of these. Maybe you want to create a couple extra of those.
Yeah, and that's kind of tiptoeing into almost like the AI ops side of the world.
Yeah.
We don't really do that stuff now, but we certainly give you the information to kind of make that decision. And some of that stuff, it should be more discretional as well, right? So
Yes.
We're using this, maybe a clear-cut example of the web tier and the booking service, and we know the booking service is the choke point. But maybe there's like a background worker that you really don't care how long it takes. It can be kind of starved for resources. You can have only one of those things. It can go do its stuff, and nobody's going to care. But maybe you have an e-commerce site, and checking out, and maybe you have, I don't know, a pricing service, and be like, that's the thing that I want to be fast, and I don't want my users waiting for. So I want to give it more replica sets, or up its number of replica sets, and take away from something else.
Definitely. Okay. And I mean, every now and again you will hear a horror story of somebody who ran Kubernetes and put those scaling parameters into it, and it scales out of control while they're not looking. And while right, what I'm talking about. You've heard these stories, haven't you, Adam?
For sure.
Right? They did a demo on Friday, and it was the end of the day. Finished the demo. Hey, we're gonna go out and have a good time tonight. Everything was successful. They come back Monday morning to a $10,000 Kubernetes bill.
Yeah, and I've seen that problem, and I would say so. There's a lot of people just going into Kubernetes. And I've heard stories of people going from on-premises monolithic applications straight to Kubernetes in the cloud. And like it's a massive leap, and there's a lot of risk there, and bad things can happen. But one of the kind of basic gotchas that I've seen is people are kind of in a hurry to get things into Kubernetes. And they might miss things like memory limits.
Yes.
So if you have an old application that somebody ported to an image in a day, and now you threw it in Kubernetes, and it's got a memory leak, or it's a memory hog. If you don't put limits on it, it's going to use everything on the host, right? Yeah. It's going to just continue to use more memory, and then Kubernetes is going to balance that out by moving some pods to another host. Yeah. And then you're going to be in this cycle of everything's just constantly being shuffled around as things are stopped as memory runs out on one node and moved to somewhere else.
It's doing a lot of work to shuffle stuff around now.
And then you've got cold starts on the nodes, and things not in memory, so that can cause performance problems in itself.
Yeah. All right. So I feel like, right, Kubernetes really it's an amazing tool. But a lot of people look at it almost like a golden hammer. We can solve all of our application issues with it. And as we're showing here, it's not necessarily Kubernetes that you need. Being able to structure and know exactly where your application resources are going, and getting this visibility into those is going to help you structure and deploy better.
Yeah, Kubernetes definitely solves a lot of problems, and I think it still is kind of the way of the future. If anybody's watching the Twitch stream, if you kind of need Kubernetes help or want to join a community, there's a Kubernetes Slack channel. There's like 100,000 people in there just talking about Kubernetes all day.
Okay.
But it introduces a lot of problems too. It's especially if you're new to it and you're moving from a monolithic application, it's brand new. It's a brand new set of problems that you need to be prepared for, and frankly, you need visibility into.
Yeah, absolutely. All right. So, good tool to have. AppOptics, being able to look into all your Kubernetes configuration out there.
For sure. And one of the things, I guess, kind of on this topic, we were talking about cloud migrations.
Yeah.
So, if you're moving from on-premises and you're moving into the cloud, I think most people kind of just move their applications as they are and don't make that initial jump into Kubernetes, which makes more sense to me. And we're talking about resource utilization and that problem of people just throwing more money at the infrastructure.
Yeah.
So AppOptics does track that as well. So if we jump over to our infrastructure, so AppOptics is usually faster than this. I think it just is my internet. So we can look at all of our infrastructure, and we can do things like group by service. So
that's nice.
We can do things like we can look at our web tier and we can see that this AO demo 1 host, that's the one everybody was interacting with.
Yeah.
That's what we can see its CPU utilization actually doing fine. Its memory, its disk IO. We can
clear
click
and sunny
into that.
there.
Clear and sunny, and then we can actually go in and see that, hey, there are actually other services that are running on this. Makes sense. It's a bunch of Docker containers. See which processes are taking up the CPU, et cetera, which is great in kind of a troubleshooting sense. But if you're wondering, hey, when I move this stuff to the cloud, am I putting the right size of instances behind this stuff? Are they the right kind of instances that I actually do my deployments across regions and availability zones properly? You can use a list like this. It works decently. We can group by service. We can group by region. We can even group by instance size if we want to. Let's do that just for fun, actually. Let's do instance type. So in our web tier here, we've got 2 T2 mediums, a T2 small, and a T2 extra large, which is a real mixed bag just for kicks. But you can kind of get that insight and say, okay, I've got my T2 mediums and my T2 smalls. I can look at my memory utilization, my CPU, and say, which one's working properly? Or should I run this on T2 mediums? Is my performance okay? Am I using all the resources on that host? And you can use this to find stuff that you're underutilizing as well.
Yeah, that's coming back to what I was saying earlier about make sure these things are running hot, right? Only 40% memory utilization, only 11%. Can we scale this down? Can we make this a smaller machine and still get away with it?
And then we can do the same thing for containers. So we can look at our infrastructure, not from a host perspective, but from, let's do, again, our service and look at our containers. We can see our different images in here, see the memory utilization, CPU on a container basis. And again, we can do things like, well, I think these are all going to be in the same, let's do region just for fun. They're all in the same region, but when some people move from on-premises data centers, you might have, maybe you have 5 data centers around the world, and you're trying to move into maybe 5 regions in AWS, or maybe different availability zones for redundancy.
Sure.
You can come in here and say, did I actually do that properly? Like, do I actually have
Wait a
the
second.
service running?
You've got all of them in US East. Didn't you want to put some in Europe and South America, Asia?
Yeah. And and how are those handling the load? Are you over provisioned in Europe and under provisioned in the US because of your traffic? So you can kind of use this to kind of right size your infrastructure.
I like that term, right sizing, because all too often, like my employer before me, I was talking about earlier, all too often we just go get, what's the biggest one I can afford, and we're just going to use that one. But to choose the right size one here, these ones, they look like they're pretty right size because that memory utilization, it's above 80%. That feels pretty good. CPU is very low, but if it's not doing a lot right now, if it's dormant, that's not bad.
Yeah, and you could kind of maybe tie it all together a little bit. If you've got a small staging or development environment and you're running load tests and you kind of understand where the choke points are, you tweak some of that stuff, you can get an idea of what kind of resources you're going to need when you go to production.
That footprint that we're looking for, that's when quality assurance folks will have that information that they'll be able to share and help to structure this. That's a really good insight there.
Yeah, for sure. And we do have, let's take a look at this too. We do have this in a map sense as well. So, this is a pretty small environment, but, if you have hundreds or thousands of containers, or same for hosts, and you want to look at just kind of from a visual perspective, what's my CPU utilization or memory utilization of, let's say, US East 1 versus, Europe West 2, and see if you've kind of right-sized your resources between those two things. You can kind of use this visual map to do that as well.
Nice. Getting that immediate heat map. Now, can you drill down on each one of those and see what's going on in the hotter elements of the heat map?
Yeah, you can do this on both on a per container basis as well as a per hostess basis. So you can come in here and actually see which services are actually running on this one. Kind of dig in even further and see which processes on a host, or which services in a container.
Very cool. Oh yeah, and there's all the utilization bar graph. Nice.
Yeah, it's got everything there. And I should mention this as well. So we're showing things like US East 1, availability zones. There might be a question of where this data is coming from. And basically, we have an integration with CloudWatch.
Okay.
So what that integration does is it pulls in some metrics like CPU and some things, although we have an agent that does that as well. But almost more importantly, it pulls in the tags. So that's where this is coming from. So nobody's going in and taking this themselves. It's just coming from the EC2 tags sitting in CloudWatch.
Now, if I were to be running AppOptics against a process that was running an application that was running on Google Cloud or on Azure, I would get similar groupings on the data center here?
We definitely work in Azure and GCP and AWS. The tagging is kind of tagging by region stuff is a bit specific to AWS. It'll be a little bit different depending on those different things, but we do have a direct integration with Azure as well. Actually, I should show you that. So I don't know if there's a bunch of people on the call working on Azure, but something I just want to show this off because we're proud of it. We've got our integrations here. We built our integration for Azure in quite a specific way. So, there are other companies out there that have integrations with Azure, but the way we did this is just super, super simple. It's basically like an OAuth style flow for integrated with Azure.
Okay.
So it just pops up, ask you to log in with Azure. You hit yes, and then your metrics are flowing into AppOptics, and you've got it all in one place.
Nice. Oh my gosh, that's great.
Yeah, Solarwinds tries to be like simple and easy to use products that still are very powerful. So wherever we can, we try to make it, kind of easier on our users, and don't send them off to read 10 pages of docs to set up an Azure integration.
Oh my gosh, nobody wants to do that, right? The more point and click I feel around some of and graphical that we can make some of these things, it makes sense for somebody to help comprehend what's going on as they're learning, as they're figuring out how to work with the tools. It lowers that barrier to entry, and it looks like you guys have done a really nice job pulling that together here.
And especially if you're in a time during a cloud migration, you're moving from on-premises, you're moving to the cloud, the last thing you want is to go set up some integration that gives you 10 pages of docs and talks about permissions and roles and how to set this stuff up. especially if you're brand new to Azure, you don't know what that stuff means yet.
No, you don't. And right, you don't want to hire a contractor to have to come in and do some complex integration. The easier that we can make these things to set up and connect and use our existing processes and source code, the easier it is for everybody.
Exactly.
Yeah. How we doing there, chat room? What do you think? There's a lot here to digest. We've seen a lot of app optics here. We've gone through. We've learned a bit about right sizing our architecture. Is there anything that we can do to monitor what happens as we're migrating things to the cloud? There's so many things. I mean, look at all these integrations here. As we're pushing stuff from my on-premises, SQL Server maybe, right, or even on-premises Oracle database. When I'm doing that migration, is there anything we can do to monitor what that looks like?
Yeah, it's a good question. So we do have a lot of integrations, and they're not even all covered here. But you can monitor things like your SQL server and all your different databases and your applications. You can get full visibility into really both sets of data, your on-premises and the data in the cloud. And one of the nice things about AppOptics is everything works on tags. So if you set up, let's take a look at our dashboard. I think we've got a Postgres one here somewhere. What I mean by tags is it's basically like different dimensions to your data. Okay. So we can look at, I think we've got Postgres. This might be an empty dashboard. We'll see. Oh, here's an empty dashboard. So whenever a time series metric comes into AppOptics, and we'll look at, let's look at, I'll look at Kubernetes again just for fun.
Okay.
So let's think about database performance. You're talking about like the amount of reads, amount of writes, and say latency. We can split that up by host. Right? We could say, hey, let's look at our host that is in AWS or on premises. You can also one of the easy things you can do is whenever you're setting up an integration in AppOptics, you're basically giving it a token.
Okay.
And we have the idea of environments on our token. And it's actually really easy when you're working across teams to coordinate. You can just give the team that's working in the data center a particular token, and then all of the data that comes in from them using that token will be tagged with, let's say, data center, or even data center 1.
Sure.
And then on any of our dashboards, you can filter down and say, hey, show me Postgres performance, but only show it for data center 1. Or only show it for AWS, or only show it for staging. And then you can kind of look at the average as well. I think one of the things that you want to look at when you're doing one of these migrations is, hey, is our performance in on-premises okay? Is it okay in the cloud? And really, is it getting better or worse? Right. So if we're looking at the amount of reads and writes and our latency, when we did this cloud migration, did we make things worse? Did we make it better? Are we over provisioned?
Yeah. Did we make the problem worse? The answer hopefully is no.
Yeah, hopefully.
My goodness. That's good to know. And to know that you have the capability to use the tool, not just on a cloud service, but in your own data center, to be able to get that insight back and forth and that important measurement, right? And it might be okay if the machine's running hotter, if you're getting the same, if not better latency, and you're spending less on your hardware resources.
I mean, they're almost opposite problems, right? When you're in the cloud, you want things to run as hot as possible. When you're in the data center, you want to avoid that.
and the operations folks have a hard time sometimes with that transition, don't they?
They do, for sure. And that actually reminds me, there's one kind of last thing I wanted to show you on per trace basis. And whenever we talk about data centers, this reminds me of this. So we've kind of focused on, when we're looking at traces earlier, we're always kind of talking about almost like the I/O activity, like database calls,
Sure.
External API calls, et cetera, but often, especially on old monolithic applications, or really there are applications that are just compute heavy, we do have something called live code profiling. It actually comes back to the development flow as well.
Yeah.
We can actually look at this request that took 300 milliseconds. We can actually break down the functions and methods of where we spent our time.
Oh, very cool.
And it does kind of play into that cloud migration of, sometimes people have this giant monolithic application that, I've seen it before where, I don't know, it takes JSON and it turns it into a CSV. It's just like some old thing that still lives around and they still need it because it performs some job, but it takes 2 minutes to do it. And there's often that question of, why does it take 2 minutes, right? Like somebody inherited this thing and they want to know why it's slow.
Sure. Yeah.
Looking at the database isn't always going to answer that question. But live code profiling, you don't have to go in and say, hey, watch these functions or use a decorator. This is just automatic. For those on the call, basically we do something called statistical profiling, where basically we look at what functions are running at a set period of time, and then we kind of aggregate that, and we can tell you what percentage of the time we saw these different functions.
Nice. All right, so it's giving you that same performance analysis and reporting it back to you. Here's where the hot methods are that are running a little bit longer, and be able to, as a developer, determine when it makes sense to start pulling that apart and do that refactoring. Yeah,
exactly. Especially when you're a developer, like you might have written something that looks really clean. Everybody likes clean code and less lines of code these days.
Oh yeah.
Maybe it's wildly inefficient, right? Like maybe you just made something that takes 2 minutes, and you're about to push it to production. But it's good to test it and see it in here first.
Oh yeah. Code golf is nice for us as humans, right? Trying to have the fewest lines of code, but really what we care about is the fewest processor cycles or a smaller amount of memory.
For sure. Looks like we got a question. Does this work with PHP? It definitely does. Yeah, live code profiling works out of the box with PHP.
There you go. And there was another question. Yeah, I wanted to give you a chance to finish there. Curious Drive, we heard a little bit. There's a developer edition that's free available. What about pricing when we go to deploy this with our AWS instance, with our Azure or our Google, or even on site? What's involved there with the with pricing? Oh my gosh! And Adam, we just got another raid. I'm sorry.
Oh, nice. So what? SolarWinds in general tries to be really easy to use and really affordable. What we often see in the industry is people really want this type of visibility, but APM solutions are very expensive. So they'll often pick and choose and put the APM solution on like a couple hosts here and there, but if the problem's on the other hosts or on the other applications, then you lose that visibility.
Yeah.
So this is priced in a way that should allow people to kind of run it everywhere, and really for everything that we've seen, so including the infrastructure monitoring, all the Docker stuff, all the Kubernetes stuff, live code profiling, distributed tracing, all of that runs for about $25 a host per month.
That's not bad. For the visibility you get per host, that's pretty good.
Yeah, I mean, certainly less than the competition.
Yeah, there you go.
Yeah.
So I want to welcome in our raiders there. We've just had 30-some folks join us from This is Fairy Wings channel. My name is Jeff Fritz. We're talking a little bit about application performance management for whatever your application is running out there on the web. Perhaps maybe it's running in your own data center. And this is Adam Hert from Solarwinds talking to us about how we can get a little bit more information about how our applications are running, where performance issues might be, and then how to right size the applications. Thank you so much for the raid, friends. Oh my goodness. It's always great seeing some friends join us from another channel right here on Twitch.
Jeff, after looking at the code profiling there, really is for developers, right? Like if you show that even to an SRE person, sometimes it's like, I don't know what this is. Right?
Yeah,
it doesn't apply to them.
This database query, is that right? Should that be right? feels like it could be. I don't know.
Yeah, and especially when it comes to custom functions. I mean, we were looking at custom Java classes in there and everything. And if it's an SRE responding to an alert at 2 in the morning, they don't want to look at Java class names, right? That doesn't make any sense to them. So we did try to build this in a way that, it's kind of like layers in an onion that, hey, here's the real simple answer. Is, this request took 88% of the time because of the database. That's kind of an answer in itself. We've got the specific database calls. And then if the developers really want to kind of get down into the details, they can click on the individual database calls in here to see the query, or they can also dive right into the code and be like, okay, so I can actually see it's actually this, class name and actually this file on this line where we're spending all this time and making all those database queries.
Yeah.
So should help teams work together a little bit to solve their problems.
Absolutely. In the chat room, Cyralash has a question here. For deployment, what if we don't have access to the hosts? Can we still see benefits from App Optics from deploying this with containers? I think we've seen a little bit of that, but
yeah, we have. So good question. So if you're running in some sort of serverless place or some kind of managed Kubernetes, most of them still allow daemon sets. So that's actually how we gather most of our data. So when we were looking at the dashboards on our Kubernetes usage, and then even the infrastructure where we're looking at our services broken out by container, pretty much all of that is coming from our daemon set. Okay. So we have, we'll just pull that up in case some of those guys missed that. So we have kind of two things for that. We've got, well, actually there's three answers for that. So for the APM visibility, where we're seeing the code profiling and the database calls and all that stuff, that is literally just a library. So it doesn't really matter where you run it. You can even run it in Heroku. And then for actually gathering infrastructure metrics from your containers to understand, just like we looked at before of, what's the average memory usage of my pods versus the sum, that's where like the daemon set for Kubernetes comes in.
Gotcha. Okay. And so we do have all that flexibility to deploy and run it wherever you need to. Really great to have that capability there. I know folks that are running things in Azure Functions or in AWS Lambda. You know how many times that the actual function has been run because that's how they're billing you. But what's the performance of that? How does that scale? And my goodness, Adam, I've seen folks who took what was spaghetti code inside of one web application and now they've turned it into globally distributed serverless spaghetti network diagnostics, and to be able to have this insight going across those, that you wouldn't have that because you've distributed across the network using serverless tech.
Yeah, exactly. And the Azure Functions and AWS Lambda, so we do have integrations for both of those things. And like we showed on the Azure integration, basically log in kind of OAuth Google style, you can start pulling those metrics in right away, and then you can add them to a dashboard. So if you want, I'll just click on a button here. If you want a new chart that is, your AWS Lambda execution times or your invocations right beside Azure Functions, right beside your Kubernetes metrics, you can do that. It's super easy.
Very cool. Love the customization on the dashboards because everybody has a different requirement. Like we were saying earlier, your application will be different from mine. It's built differently.
For sure. And these are super easy to edit and change. We've got customers that take this kind of to the nth degree that they use things like Terraform, and they actually manage their dashboards in Terraform.
Oh, wow.
So just they have a check that goes, and we've got a Terraform provider that does this. So they just they have all of their alerts and all of their dashboards and kind of their custom configuration. It's almost like monitoring as code, and it's just part of their Terraform, and it just is managed in App Optics through that.
Gosh, I hadn't thought of that. Monitoring as code. Like when we do containers, we're doing configuration, system configuration as code. So to take that next step and make our monitoring as code, that's an interesting next step. Okay, I can buy that. Sure.
You know what? I think people are kind of getting more towards that with the SLOs and SLAs. Is that you can in Terraform, when you're deploying these services and you know what your SLOs are, you can just set alerts on that service right in Terraform. You don't even have to come into the product, and then when that service level objective is passed, then you got a message in Slack and you know what's going on.
Nice, very cool stuff.
And actually, I should show that on here. So,
do you have it?
So you can also do snapshots on here. This is actually super handy. I don't show this often enough. But you can see a chart, and you can just send this directly to a Slack channel. So
nice.
our internal SREs use this all the time. So if somebody's responding to an alert, and other people are busy and they don't want to necessarily log in right away, you can just send a chart directly to a Slack channel.
Very cool. Oh, that's great. We're nearing the end of our time together here. I want to just check in and make sure that our friends in chat have their questions answered here. We've done a lot here together. My goodness, I love the question about PHP. That's so cool.
There's still lots of PHP out there.
There is, right? The joke that I hear from folks is PHP is either WordPress or people or Facebook.
It's not that. There's still a ton of people out there using PHP. It's still people poke fun at it, but still it's an easy language to use.
The interpreter running and being able to deliver a nice application that anybody can really pull apart and see the code easily. It's undervalued, I think, a bit in the software industry. And I've seen folks, and I've mentioned this project a couple times here on my channel. Some folks wrote a project called Peach Pie. Have you heard of this, Adam?
I haven't heard of this one, no.
So Peach Pie is a PHP compiler that sits on top of Dotnet Core.
Okay.
So Dotnet Core has this really fast web server called, oh my gosh, I'm blanking on it now. I want to say Kubernetes, and that's not it. Why am I blanking on the name of the web server? Because it's
IIS?
No, not IIS. It's the managed web server that ships with ASP.NET Core. It starts with a. I'm blanking on this completely. I can't believe this. Chat room, help me out. What's the name of the ASP.NET Core? Kestrel. Thank you, Canhorn. I should know these things. But it compiles PHP to run on top of Kestrel as a native .NET DLL. That's kind of out there, right? To be able to interpret and compile PHP to .NET. But they're seeing performance improvements from this, right? That's someplace where things that want to hook in and give these types of diagnostics are going to could get a little bit confused because they're seeing .NET coming in, but somehow it renders back as PHP. Interesting stuff, to be sure. But people trying to squeeze stuff out of PHP like that and alternative PHP compilers, really great to see that innovation.
It's fascinating. Wasn't it Google that made compiled Python at one point too? I mean, people do some amazing stuff with those old languages.
Yeah. Elliot Brand asks, do you have to recompile every time you update a plugin with the PHP to the PeachPy compiler? You do, yes, but the idea with that is, of course, you're not right because PHP is interpreted. I don't know if you've seen this, Adam, but right, folks can upload into your WordPress application rogue PHP files, and it just picks them up and starts running. Yeah,
and you know what? That's actually somebody had a question about. Do we have that live code profiling for PHP? Honestly, the majority of the use cases is where people have a slowdown because of a third-party plugin, right? So the website is slow, and they're like, I didn't make a change. I don't know why this thing is so slow. I don't know where we're spending our time, and it's some third-party PHP module that's just spinning in circles, taking up all the CPU.
Yeah, you got to know what you're relying on. You got to know a little bit of what those third-party modules do.
Yeah, I mean, PHP it's not as bad as Node modules, but there can still be a lot of them, right? Yeah,
that's where I was going. Yeah. That JavaScript community is tremendous. That they're all, it's the bazaar, right? You've got all these little tables, all these little packages that have been built around the bazaar, and you pull them together, and you've got something really cool that runs.
Yeah, I feel like in JavaScript we're going to be in some dependency loop at some point, and it's just everything's going to be broken there. But
yeah, it's coming.
Yeah.
So my gosh, this has been really great, Adam. Thank you so much for sharing a bit of this with us here, because sometimes I struggle with how I get insight into my applications. Why is this running slow? And as I look at the new things that I want to push out and deploy, and I've even got a website I'm getting ready to deploy to show some sample Blazor code that we're writing, code that runs on the server using ASP.NET Core, to be able to get insights like this into how my application is running. It's going to be tremendously valuable for me as I move forward with my project. Thank you for sharing.
Yeah, happy to help out. And like I mentioned, AppOptics Dev Edition is totally free. You get live code profiling, you get dashboards like this, and a bit of infrastructure monitoring. Should make your life a little bit easier.
Yeah. All right, friends. This has been really cool. Thanks to our friends from Solarwinds for sponsoring today's stream. Just like the folks that we had join us, Adam, through those raids, this is kind of like old-time radio, where you have the DJ do the crossover and pass over to another stream. So if you don't mind, I'd like to set up and send folks over to another streamer that's running right now, that they're actually doing a little bit of coding over there. Maybe they can use a little bit of AppOptics. I want to send folks over to Code It Live. So these are our friends that are over on, they're with Progress Software, and they're building some things as part of a codathon today. They're calling it the Quarantine Hackathon. I wouldn't know anything about people being quarantined this time of year. I don't know what that is. So friends, here's what I want you to do. If you're in the chat room, I'm going to put the raid call out, and what I'm going to recommend you do, there's 2 lines in the chat room. If you're a subscriber, copy the top line. We're going to announce ourselves loud and proud when we go over to see the Code It Live folks. If you're not, grab the second line, and we're going to head over and say hello to our friends over there at Code It Live. All right, and there's the raid. Thank you so much. There we go. There's Adam. Thank you so much. This was great. This video, like all of our other videos, will be available over on the YouTube channel, and we're going to get a copy over to the folks at SolarWinds along with the transcript. A lot of fun, Adam. I really appreciate the insight.
Yeah, thanks for having me on the show.
Alrighty, and friends, get ready to say hi to Code It Live. We'll see you over there in just a little bit.